axons. Okay. Another terminology that and terms that we need to see is sometimes when we have axons bulging and showing us a specific feature of the brain, they will get some names. So you guys, as we proceed in the brainstem and get into the midbrain, you're gonna hear a word that is called brachium. You're gonna see the superior brachium and inferior brachium. Brachium means arm. Brachium is nothing but a bulging axon seen from the surface of the midbrain. All right, so brachium means arm in Latin, and you will get to see it, and that means nothing but the myelinated axons that are bulging outside and seeing as an important feature in the midbrain. Another important thing is the peduncle. You get to hear peduncle twice in the nervous system. You will hear something called cerebral peduncle. You will hear something called cerebellar peduncles. We have superior, we have middle, and we have inferior peduncle, cerebellar. What does peduncle mean? It means a foot. If you guys think about your brain, and that brain is actually standing on a foot, all right, this foot is gonna be your cerebral, coming from cerebrum. It's your cerebral peduncles. What is the first part of the brain stem do we have, guys? It's actually the midbrain. So where do you expect your cerebellum is standing on its foot? It's standing on its foot in the midbrain, because your midbrain is actually the first part of the brainstem. You have the midbrain, you have the pons, and you have the medulla. So where do you think that the cerebral peduncle is? It's actually in the first part of the brainstem. If this is your brain, this is your brainstem. The first part is your midbrain. So the cerebral peduncle, the foot of your cerebrum, is actually situated in the midbrain. It's actually a part of the midbrain, and we're going to talk about this. We're going to talk about them into details in the midbrain videos. All right. What about the cerebellar peduncle? It's actually the feet of the cerebellum. You have two cerebellar hemispheres. You have right and you have left, and they have 3 feet. 1, 2, 3. They are standing on 3 feet. One connecting the cerebellum to the midbrain up, one connecting the cerebellum to the pons in the middle, and one connecting the cerebellum to the medulla down. So we have superior, we have middle, and we have inferior cerebellar peduncle. So now you guys know that the peduncle is basically the axons traveling up and down between the cerebellum and the elsewhere in the brain, and also between the cerebrum and elsewhere in the central nervous system. And whenever we have them, we call them peduncles. All right, these are the feet of your cerebrum or cerebellum. The next thing is the axons that cross from one side to another. If you have a group of axons traveling from one side to the corresponding, the same side, the same area of the other side, we call it a commissure. So if I have a counterpart, I have a commissure. The corpus callosum is the biggest commissure of your body. Corpus callosum, you'll get to see it as we talk about that in the brain. But just to know that axons, they have different names and terms in the central nervous system, and one of them is the commissure. And commissure means that these axons are connecting the same region on the other side of the cerebral hemisphere, and they are important because you guys need to have the information from one side connected to the other side, so that the information becomes integrated in your brain. You have another term, which is the decussation. Decussation means crossing to the other side. If you have a tract that crosses to the other side, we call that the decussation. And the decussation is nothing but the axons crossing to the other side and ascending. And you will have this a lot as we proceed in the system, and we're going to hear about that as we proceed. So this is just a term, and that will make your life easy as you get to know more details about these things in the coming topics, all right? Okay, so as a recap, we talked about where the axons can be seen, the different names and terms we get to hear when we see an axon, like the axons, group of axons, sorry, and that is the brachium, the peduncles, the commissures, and the decussation, all right? Now, we have more terms, and one of the terms is the tegmentum. What is that? It's the tegmentum, you guys. What is tegmentum? Whenever we have structures that are forming the core of the brain stem, we call it tegmentum. Tegmentum in Latin means covering, means surrounding. And because this is a part of your brain stem that surrounds the cavities of the cerebrospinal fluid, you guys know that you have the CSF that is floating around your central nervous system, and parts of that in the brain stem is these areas where you have the fourth ventricles and the aqueducts, all right, and the central canals. And this is actually the first part of a tissue in the core of the brainstem. So the tegmentum is the part that has important tracts and axons, cranial nerve nuclei, and this is what we mean by tegmentum. We're gonna see that as we proceed. I'm gonna mention it more times in the respective parts of the brainstem, but this is just a general terminology to show you where you can find the tegmentum and what does it mean. And then now we have the tictum. Tictum, if you guys look at the brainstem, you have the midbrain here. The midbrain has a tictum and tegmentum. This is the midbrain. It's the first part of your brainstem. And here you have the pons. The pons is the bulging part here, and here you have the medulla. All right. So if you hear the tictum, tictum means roof. All right. So this is actually forming the roof of the cerebral aqueduct. So this is a part of your midbrain, and we're gonna talk about this in more details in the midbrain. And then you have something called the base. When we refer to a base of your brain, you need to know that the basilar part is your ventral part. Why is that? That's because you guys, your brain is sitting on the cranial cavity, because here is your cranial cavity, right? Here is your cranial cavity. So it makes sense that the ventral part is the basilar part. So when we say basilar part of pons, remember that this is the ventral aspect of the pons. It's where you get to see the basilar artery. The basilar artery is actually this artery, the artery that sits on the ventral part of the pons, all right? Now we have the floor of the wall or the wall. What does the floor means, or what does the wall mean? It's when you have the ventral boundaries of your ventricles. You will have ventricles, and then when you have the ventral boundaries of the ventricles, like for the fourth ventricle, you will hear the word wall or the floor, all right? So these are terminologies, yeah, that we will say them into more details, and here is a summary of all of them in case you want to take a screenshot or you just need to remember them back. Okay, so I already mentioned about the gray matter and white matter, and here is just one more time to show you that the gray matter are grouped as H-shaped in the spinal cord, and the white matter is outside. And this organization of the gray matter that has the cell bodies of your neurons is going to divide your white matter into posterior column, lateral column, and anterior column, or funiculi. All right. So funiculi means groups of bundles of axons, cords. All right. These are all myelinated axons. That's why they are white matter. And here we have the white matter. All right. And then here outside, you have your gray matter in the cortex, and you have them deep as well in the caudate nucleus and parts of the basal nuclei. Like I said, the nuclei are group of cell bodies in the central nervous system. All right. Now, what are the parts of the nervous system? You guys know that the parts of the nervous system is basically your brain and spinal cord. Why do we consider them as a central nervous system? Because this is your control unit of the body. Because basically, once you have a sensation outside, you need to collect the information by the receptors, and then you get the information all the way to your spinal cord, and from the spinal cord, you get to the brain. So this is why we consider the brain and spinal cord as the central nervous system, all right? Because this is the control unit of your body. Okay, another classification of the nervous system is actually when we say that we have a peripheral nervous system. So if I'm not in the central nervous system, the brain and the spinal cord, the control units of my body, it means I'm in the peripheral part that needs to transfer the information from the environment. It links the surrounding environment to my central nervous system. Okay, so the brain and spinal cord are the central units of my body, but thanks to my peripheral nervous system, because the periphery is going to catch the information in the surrounding, all right, and bring this information all the way to my central unit so that I can control it, I can understand what's going on, and I can interpret the sensations, and I can also bring the motor information from my boss, which is the brain, all the way to these nerves, and then I can affect or cause a function to the motor units like the muscles, the glands. So I either have sensation from the surroundings, so I'm going to grasp it by receptors, and from these receptors, I'm going to transfer them through the nerves, cranial nerves, if that is in the head and neck, or spinal nerves, if that is in my body down. I'm going to collect this information and I'm going to transfer them into the central unit so that I can take it all the way to the brain, and I can understand what is the sensation, and I can feel and I can appreciate what's happening around me. And the opposite is true. Whenever I have a motor innervation, whenever I have control over my muscles, I need to move my hands, I need to for example, I need to cause an effect on a gland, let's say autonomic innervation. That is going to also happen by the connection by those nerves to the glands or the smooth muscles autonomically. So that will take me to the next classification of the nervous system, which is the autonomic. So the autonomic nervous system is basically part of my nervous system based on the function. It's whenever I have an involuntary control, but it's nothing but peripheral nervous system. So when we say central nervous system and peripheral, we are classifying based on the structure. If I have a boss, someone who's controlling, this is going to be the brain and spinal cord. This is central nervous system. If I have a peripheral nervous system, it's what connects the central to everywhere else, the glands, the muscles, wherever. And that is a structural classification. Now, to further classify the peripheral into a function, it can be, like we said previously, somatic, whenever I have a voluntary control by cranial nerves in head and neck and spinal nerves in my body. This is going to be the somatic nervous system, voluntary. If I have autonomic, it means the sympathetic, the parasympathetic, and the enteric nervous system. Sympathetic, which is the fight or flight mode of my body. I need to do autonomic control, something that I don't have control over it. My brain just controls this based on the hormones and the stimulation I have. And fight or flight is for the sympathetic, and rest and digest for the parasympathetic, and then we have the enteric for the viscera. All right, so in that case here we have the autonomic nervous system. So again, like we said, in the central nervous system we have the brain as the center, and then we have the brain, of course, here, and the spinal cord is down. So this is the central part of my nervous system. And whenever I want to connect my central unit to the surrounding, I need to have the cranial nerves in head and neck, and I need to have the spinal nerves in my body. And that is to connect and link my central nervous system to the surrounding. And then we have the autonomic nervous system, and that can be seen in the sympathetic, like the sympathetic chain. We have the paravertebral sympathetic chain, or the prevertebral sympathetic ganglia in front here, in front of the spinal cord, in front of the vertebral column. So these are all sympathetic, all right? And then we have also the parasympathetic ganglia, and the parasympathetic can be seen as the four parasympathetic ganglia of head and neck. I have four, and we're gonna explain the parasympathetic nervous system into more details in a separate video, maybe at the end of the module. And so this is the parasympathetic, and also we have the pelvic splanchnic nerves, of course, is part of the parasympathetic nervous system. And then we have the enteric nervous system, which is part of all of them whenever we are controlling the viscera, all right? Whenever we have sensation, we are bringing the information from the organs and from the surroundings to the brain. And whenever we have a motor control, the information is coming from the brain, from the boss, all the way down to the final target, which could be muscle, could be gland, whatever. Now, again, what's the difference between the nuclei of the brain and spinal cord and the ganglia? Like I said, if we have a group of cell bodies in the central nervous, remember that was my neuron? That was my neuron, guys. All right. So if I have a group of cell bodies in the central nervous system, I call it nuclei. That's why we should not say basal ganglia. We should say basal nuclei, and because this is the brain, this is the central nervous system. Okay. And if we have a group of cell bodies outside the central nervous system, we call it ganglia, like the dorsal root ganglia. Here we have cell bodies, but that is outside the central nervous system, so I call them ganglia. We have the somatic ganglia, like the dorsal root ganglia, and we also have autonomic ganglia, like the ganglia of the sympathetic system, and that is the motor ganglia. So the somatic is sensory, like the dorsal root ganglia, and the autonomic example is motor in terms of ganglia. Thank you guys for watching, and see you in the next videos.